minus 7x plus 6. We have that that's minus 6 cubed minus 7 times minus 6 plus 6. And you probably see that this isn't going to work either. That gives us minus 216 plus 42 plus 6, which is going to give us, well, that's 216 and, sorry, it's minus 216 plus 48 is going to give us 168. So you can actually see that minus 6 is not a root. So from the rational root test, which lists, when you list the factors, once again, when you list the factors, when you list all the factors of A0 and when you list the factors of A3, and when you look at the rational combinations of them, plus or minus them, in this particular case, what we ended up with is we ended up with 2, 4, 6, 8 possible roots to this particular polynomial. What does it mean to be a root? It means that when I substitute any one of these in, I get 0. So what we actually now know is this, is that from our particular polynomial function, we know that x is equal to 1, x is equal to 2, and x is equal to minus 3 are roots. Okay, so actually they're the solutions. So if you're looking to solve the polynomial function by using the rational root test, these are the actual solutions. What do these mean? So let's just keep this in mind. So what do these actually mean? Okay. So, well, we now know, okay, that x is equal to 1, okay, x is equal to 2, and x is equal to minus 3 are roots. What does this imply? Well, this implies that x minus 1 is equal to 0. This implies that x minus 2 is equal to 0, and this implies that x plus 3 is equal to 0. So all of these three numbers are actually equal to 0, which means that their product is going to be equal to 0. So this implies that x minus 1 times x minus 2 times x plus 3 must be equal to 0. Let's multiply out these two terms here. So this becomes x. This implies that x minus 1 times x gives us an x squared. X times 3x gives us a positive 3x. Minus 2 times x gives us a minus 2x. So the 3x and the minus 2x gives us a positive x, and the minus times the minus gives us a minus. 2 times 3 gives us 6. That this must be equal to 0, which implies x, multiply out the brackets again, x times x squared gives us x cubed, x times positive x gives us an x squared, x times minus 6 gives us minus 6x, the minus 1 times the x squared gives us a minus x squared, the minus 1 times the positive x gives us a minus x, the minus 1 times the minus 6 gives us a positive 6, must be equal to 0, which implies that x cubed, bring the terms together, we have x squared minus x squared cancels, so there's no x squared term here. Minus 6x minus x gives us minus 7x, plus the 6 must be equal to 0, which is exactly the polynomial that we had earlier. Okay, this is the polynomial that we started off with. Okay, so using the rational root test, what we were able to find was, using the rational root test, we were able to find all of the roots, all of the solutions to this particular polynomial. Now, in this particular video, I just wanted to show you, okay, that when we go through all of the possible roots, okay, all of the possible roots, it doesn't, this rational root test tells us that these are possible roots. Okay? It is possible that none of them give us 0 on substitution, okay, which means that there's no rational roots of the polynomial. Okay? But in this case, there was 3. But we didn't need to do all of this particular process. Okay? When we find the first root, in this case, x is equal to minus 1, what we know is this, is that, okay, when we found the first root, okay, so when we found the first root, what we now know is this, is that x, the first root, let's say, was x is equal to a, okay, well then this implies that x minus a is equal to 0, that this thing here is a factor. Okay, so what we now know is that x minus a times some other polynomial, okay, must be equal to the polynomial that we started with. Let's say some other polynomial, let's say p2 of x, must be equal to p1 of x because it's a factor. Okay, which basically means then that we can calculate the rest of the stuff. We can calculate the polynomial that we need to multiply x minus a by to give us p1 of x by actually just, so we can calculate p2 of x by dividing P1 of x by